This is a very important problem for coding interviews, especially for all the FAANG companies, because it has been asked quite a few times in all of these FAANG companies, and it's called maximum product subarray. So if you have solved maximum sum subarray, which we solved using Cadam's algorithm, then this solution will be inspired from that idea. So here we are given a list of integers. It will have positive and negative. That's the only challenge, because if everything is positive, then there is no challenge. Multiply everything. Similarly in the sum case. So there are a few challenges due to 0, because if you have to find subarray and not just subset. In subset you can pick random elements, but in subarray it should be a contiguous chunk from this original array. So if you include 0, no matter what other values are, this entire thing will be 0. So 0 has an important role to play. Similarly, negative numbers have an important role to play. So if you have a subarray which has just one negative number, then no matter what other numbers are, excluding 0, then the entire thing will be negative. If it has two negative numbers and no zeros, then entire thing will be positive. So that's why negative and 0 play very important role here. So let's take an example and we will understand our logic with that example. So let's say we have let's say -3, 2, -4, 6. Let's add a 0 also. -8, 5. So this is a good enough example and we will cover all the scenarios. So what is a subarray? First of all, it will have one index that will denote the start of subarray, and this index should be from this to this. Here it's 0, 1, 2, 3, 4, 5, 6. So this is the start index and this is end index, last index of the subarray. So these has to be between 0 and 6, including both. So how can we find it? So let's say we have to break this problem. Of course, I'm not talking about the naive solution. First of all, if you have to find all such pairs, then there will be n square possibilities. So that is the naive way of doing. So you can list down all the n square substrings, subsets, subarrays, and check their products. So that is very naive. If you don't have any solution, you can start with this in the interviews. But obviously this will not give you too much of credit. So we are talking about the optimized solution. So how can we break it? So whenever you encounter a problem, you have to think, how can I break it? Or how can I solve it progressively? So we can start from left. If you have solved the sum array case instead of product, you would be familiar with this. So let's say you are given just one element. Then what will be max and min? Max ending here and min ending here. Why are we keeping min? We will come to that. And there is one additional constraint mentioned in the problem, that you are not allowed to select empty subarray. That is, you have to pick at least one. I think this was mentioned. Let's do it again. Containing at least one number. So you cannot leave it empty. So even if everything is negative, you have to pick one. So that's why here, if it's negative, we will pick it. So maximum ending here will be -3 and minimum will also be -3. So why minimum? Let's see. So we have, let's say, some subarray, and we had seen till this index, and till this index this was the best subarray we had found so far, that is with maximum product. So when we look at this next element, either we will extend this previous one or we will not extend it. So let's say the previous one was negative. So previous one was negative, this part, and this part is positive. Then we will not include it. We will just take this one, because this is negative quantity and current element is positive. So if we multiply everything, it will be negative only. So we have a better solution, that is, if you take just this element, this will obviously be better than this, extending this. So we will take this one. Now let's say this is also negative. Then what we will do? We will check what is the minimum so far. So if the current element is negative, then whatever was the minimum subarray that we can form, which ended at previous value, and if we multiply that, so this is the smallest possible value. So it's negative, let's say. Then if we multiply this with the smallest negative value, then it will become the largest possible positive value, since it will have odd number of negatives, so this will make it positive. So this min is important here. This max will not do. Let's say this max was 10 and this is negative. So if we take just this value, then we will get a negative value. If we multiply it to this one, it will be even more negative because it was already 10. So let's say this is -2, it will become -20. So this is even worse. So both of these we will not pick, and we are keeping track of the minimum that we can form, and hopefully this was a very large negative value, and this -2 will double its magnitude but change its sign, so it will become a big positive value. So that's why we are keeping track of minimum. So also let's understand what are the roles of 0 and negative, how they differ. So let's say 0 is here and here also. Now there are some values. So let's say one case is that you include this 0 in the subarray, then this will be 0. So this kind of resets it. So you lose any significance of numbers before this. Any calculation you have done for max or min, as soon as you reach here and you decide to include it, everything becomes 0. So it kind of resets it or breaks this array into different chunks. So you can treat this part, this part, this part, so it breaks it. And what does negative do? Negative will flip it. Flip a large negative value will become large positive value, and the positive will further improve the positive value. So we need all the three. So you can write it based on case also, like you initialize with the first element. For first one, you have nothing to compare, you have to take this. So you can write like, let's say we have a function f and this array is a. Then you have max so far, or rather this is the global maximum. So let's call it overall max or max overall equal to a0. Let's say we are assuming that it will always have at least one element, since the problem mentions that we have to take one element at least. So this is max overall, max ending here, this will also be same, and min ending here, this will also be same. Then we have to run from 1 and not 0 to n-1, where n is the size of this. So you can write if ai equal to 0, then what will happen? This will become 0, all of these will become 0, max ending here, because ending here means we are including it. So as soon as we include it, positive, negative, everything becomes 0. So this will become 0, min will become 0. If it's positive, if the current value is positive, then we check if max ending was positive, then we will multiply it. If max ending was negative, we will take just the current element. So this you can write. Similarly for min ending, if min ending was positive, then just multiply it with the max ending. So whatever is the max ending, and if that is positive, multiply it, that will become further positive. So that will be the max. Or you can do just one thing. Why keep track of so many conditions? Although you can exhaustively write it and it will be very close to your understanding. But let's see, we can do it in shortcut. So why worry so much about that? Just see that max ending here equal to max of three things. Current element. When max and min were both negative, then multiplying current element, which may be positive, would make it further negative. So in that case, we will pick just current element. Or max ending here multiplied by current element. So let's say this was a good positive number, so and this is also positive, then multiplying will help. So we will take that in that case. And min also has a special role to play in the scenario where AI is negative. So this is this case where min ending here will help. Min will keep track of the minimum possible value till this point. So this is a large negative value, and this current value is also negative. So it will become a large positive value. And we will not get that by max, because max may be a positive value. So multiplying it will not help. So it will be in all the cases that you can exhaustively write, it will boil down to this thing, that max of these three quantities. So this we will do for each index, and also we will compare this max with this overall max. So this overall max will be updated whenever we get a better solution, and finally we will return this. Similarly, min ending here will be min of this one, min ending here multiplied by all three quantities. But you are not doing them simultaneously. These are previous indices value. So once you write this, max is updated, so you cannot use this. So before doing this, save it in a temp variable, and that should work. So let's write this, let's implement this logic. So if you have not understood it clearly, then pause for a moment, think of it. What are all the scenarios? First, write it exhaustively using this kind of logic, that AI is 0, AI is positive, AI is negative, and then within that also check what is max and min, whether they are positive or negative. And ultimately it boils down to this scenario, that we will be always comparing these three for taking the max and min. So first we will write in C++. nums 0 and I forgot to mention the time complexity. What should be the time complexity? We are just scanning this array from left to right, and that is just one pass, and we are keeping three variables. So time complexity is O of n, space complexity is O of 1. Also let's complete this. So this is max and min. Here max will be this current element 2, product of max ending here, that will be -6, and min ending here -6. So we will pick 2, and min will be -6. Now max will be this min multiplied by current, which is 24, and min will be take all three, that is it's -4, -8, so it will be -8. And then max will be 24 multiplied by 6, that is, so what is this 24 signifying? This -6 is signifying take these two, and this 24 is signifying whether you take just this or these two or these three. So this 2 was for max, so this -6 incorporates these two, and we multiplied this to this, so we are taking everything. Then we have 144, and then -48, then here it resets 0 0, then 0, take it 0, then min will be, so you can calculate the rest. We got a max here. I don't think we can get any better, because once we include 0, that will be 0. So this is the best you can get. So this max ending here has been updated. We want the previous value. So if we have more than 2, then we need to include it in this list, initializer list. Now it works. Now let's take our own example that we took. So it was, I guess, -3, the first one, then we had 2, then -4, 6, 0. -8, 5. And we calculated 144. And it matches with our answer. And the solution is accepted. It's here. You can try a few times. It can go left or right. That much of variation can be there. Now let's write it in Java and Python. Here you cannot assign multiple values. You have to do 2 at a time, this max and min functions. That's why we have to compare 3 numbers, so we have to take it 2 times. And the solution is accepted. Finally, we will do it in Python 3. And the Python solution is also accepted.